Hello people, I understand this following copper activity is driving some of you guys crazy. So let me see if I can help you with it. Basically what's happening is you're starting with a certain amount of copper, 4.3 grams. You react it with something else, and then it forms two different substances, well three. But the copper is not pure copper anymore. Now it becomes copper 2 nitrate. Same amount of atoms over here, but just bonded to something different. So let's dig in and see what the balanced chemical reaction is going to look like. So the first thing I do is I have the copper metal. That's just Cu. If you want, you can put a little S there to let you know that it's solid. And then you're going to say it's going to react with nitric acid. That's hydrogen nitrate. Now before we move on, we got to determine is this a neutral formula? Hydrogen is +1, nitrate ion is -1. We're good. All right. So let's move on. This stuff mixed together makes copper 2. What's that 2 mean? It means nitrate, nitrous -1, we'll need 2 of those, and NO2 and water. Sorry, this is sloppy. Then we have to balance it. And you guys did the work in class, and you know then when it's balanced, the formula is 1, 4, 1, 1, 1. But, so we've got this equation here, but what really matters here is what's going on. We're trying to track the copper. So the copper starts as just solid copper metal, but then it ends up as copper 2 nitrate. So these are the ones we care about. So let's just kind of highlight this. Copper, nitric acid, hydrogen nitrate, and copper nitrate. These guys over here are very nice, but they're not relevant in this, so we can kind of ignore them for right now. All right, so the way you do this now, you're going to have 2 problems. Every single time you do one of these Stoich problems, you have to consider 2 things. If I use all of my first reagent, how much of the important product gets made? You work that out, and you do the same thing with this. Well, if I use all of this, how much can I make? And then you look at the 2 amounts, and you take the lesser. So I'm going to get started. Here's the first one. I'm going to go from grams of copper to, what do you think? You want to go to grams of copper 2 nitrate or moles? Moles is easier. It's one less step. Let's do that. But I can't do that directly. So I have to do it in another step. I'm going to add one in the middle there. Let's say instead, from grams of copper, moles of copper. Then I can go to moles of copper. Why is that possible? Because now I can use my mole to mole ratio, which I get from the balanced chemical reaction equation, which is cool. So now I have my sandwiches. First piece of bread on bottom, it's grams of carbon or copper. On the top is moles of copper. Second sandwich, moles of copper on bottom, moles of copper to nitrate on top. And you put the numbers in. Copper is 1 mole is 63.5 grams. So we'll write that in there. All right, now moving over here, got the mole to mole ratios here. We take a look up here. Moles of copper to nitrate. Right there, I see nothing, which means there's a 1. Moles of copper right there, I see nothing, which means it's a 1. And then multiply that through. Here's what we call our tool. This is our unit multiplier. This is our conversion tool. And we start with 4.3 grams of copper. And we just make sure everything cancels appropriately. So, red pen. Grams of copper on top, grams of copper on bottom. Moles of copper on top, moles of copper on bottom. Everything checks out. We do the math. And when we multiply, 4.30 times 1 times 1 divided by 63.5, we end up with 0.0677 moles of copper to nitrate. Okay, so what we just figured out there is if I use all the copper, how much copper to nitrate can I make? Now you have to do the exact same thing, but with the hydrogen nitrate or the nitric acid. So let's do that now. We're going to go from grams nitric acid to moles of nitric acid to moles of copper to nitrate. Good. First one is grams of hydrogen nitrate, also known as nitric acid, moles of nitric acid on top. Second one is moles of N hydrogen nitrate on bottom. First one's on bottom, second one's on top. Moles of copper nitrate. Put the numbers in. We know that there is a 1 to 4 ratio here. Check that out. That 1 comes from here. That 4 comes from this. Then we look over here. We know that 1 mole of nitric acid is equal to 63 grams. There's our unit multiplier. That's the device we're going to use. Multiply through. And this time we had 18.06 grams of nitric acid. 18.06 grams of hydrogen nitrate, nitric acid. And then before we do the math, we check to see, do the units cancel? Grams of nitric acid, moles of nitric acid, moles of nitric acid. What are we left with? Moles of copper 2 nitrate. Hey, that's the same as that. Awesome. So we do our math and we find that 18.06 times 1 divided by 63, then divided by 4 equals 0.716 moles of copper nitrate. So now we've got two different amounts. What's the deal? Are we going to make 0.0716 moles? Or are we going to make 0.0677 moles? Well, that's right, the top one. Why is that? Because we only have enough copper to make this much. Sure, I've got a ton of hydrogen nitrate, nitric acid. So much of it that I could make so much more of the same thing if only I had enough copper, but I don't. Copper is gone when I make 0.0677 moles of copper 2 nitrate. So now let's find out how many grams that is. I'm going to take up some space down here. I hope you write more neatly than me or on a separate sheet of paper. So now what we know is that we're going to make 0.0677 moles of copper nitrate. So the next problem says you take that copper nitrate, your copper 2 nitrate, stuff I just made, now you react it with 6.234 grams of sodium hydroxide. So we start over again. We've got copper nitrate plus sodium hydroxide. You got to figure out what it's going to make. Well, you know copper is 2 plus. This is nitrate's -1, sodium is +1, hydroxide is -1. So copper can only possibly come together with hydroxide. But this is +2, that's -1. So you need 2 of these guys to be neutral. You might say, wait a minute, there's not 2 there. That's not your problem. Right now, just get them neutral. +1, -1, neutral. +2, -1 times 2, neutral. Good. Then what's left over? Sodium and nitrate. You say, well, wait, there's 2 here. Yeah, there have to be 2 here because copper's 2 plus. How many do you need to neutralize that +1 sodium? Just 1. You're good there. Now, sensibilities are right. This doesn't make sense. There's 2 nitrates here, but only 1 here. How do you fix that? Now you balance. Let's put a 2 here. Now I've got 2 nitrates, 2 sodiums, but only 1 sodium. Let's put a 2 here. I've got 2 sodiums. Cool. 1 copper, 1 copper. 2 nitrates, 2 nitrates. 2 sodiums, 2 sodiums. 2 hydroxides, 2 hydroxides. Okay, bueno, you're done. And now you do it again. You use your copper 2 nitrate, which is 0.677 moles. That's what this is. Let me link that together for you. Is this. And then you do it again with this other stuff, which is right there. See, but you can read it on your paper. And then you keep going. Whichever one makes the least amount is what you do when you keep going. Now, when you get to the very end, you're going to be asked this question. You should end up with less. I'll tell you right now what you should end up with. If all goes well, you should end up with 2.5 grams of copper. Now, you started with 4.3 grams. That's what you started with. Minus your 2.54 grams. And you end up realizing that you have lost. It would be 1.76 grams of copper. Just disappeared. Where'd it go? Well, let me give you a hypothetical. Might help you think your way through this. Let's look at this first question. Now imagine that the math had gone differently. that at the beginning, instead of having 18.06 grams of hydrogen nitrate, let's say you had 9.03, half as much. That would have given you half as many moles of this stuff. So you would end up with something like 0.0358, something like that, moles. This would be the lesser amount, so this is how much got made. And what that would mean is that your nitric acid, 9 grams of hydrogen nitrate, your nitric acid, was gone. It ran out when you made 0.0358 moles of copper 2 nitrate. So the question becomes, does all the copper get used? Because if you use all of your 4.3 grams of copper, it would make this much, but you don't have enough hydrogen nitrate to make 0.0677 moles. So I guess what I'm saying is that if this stuff runs out, the copper's done getting used up and not all of it gets used. Some of it gets left behind in the state that it was before the reaction started. Think about that for every problem here. If copper is ever not the limiting reactant, it stays behind in the form that it was before the reaction started. It's a complicated sentence there, but it makes a lot of sense. I'm going to say it one more time. If copper is ever not the limiting reactant, that means it stays behind as the chemical that it was before the reaction started. All right, think about that. That should help you answer this question. Good luck. See ya.